Let's look at a couple of cases where a function is not differentiable at a point, okay, where the derivative does not exist at a point. So case number one, we're interested in the function f of x is equal to the absolute value of x minus 1 plus 1. And we're interested in determining whether or not f prime of 1 exists, which means that f of x should look like a line when x is equal to 1 if we zoom in enough. So let's let the calculator help us out. Let's slide this over, and I'm going to bring in the calculator. Okay, so there's our function, the absolute value of x minus 1 plus 1. You can choose zoom decimal to get a pretty good view of it. You see I have a graph that comes down and it goes back up. It's a V graph. Okay, and we're going to trace over. We're interested when x is equal to 1. So I'm going to trace to 1 and hit enter, which puts me right down there at the bottom of the V. Right. So let's do what we did the previous time and let's zoom in. So zoom, we're going to zoom in when x is equal to 1. So I'm going to hit enter, and I'm zooming in, and there's I'm a little bit closer to that V. Okay, it's not aligned yet, so let me zoom in some more. I'm going to hit enter again. Basically get the exact same graph. Well, maybe I need to zoom in more. Okay, and no, it's not going to make a difference. It doesn't matter how many times I zoom in. Okay, it turns out that I'm just going to keep getting this V graph. Okay, so the idea is that the slopes from the left side are negative. The slopes from the right side are positive. And obviously positive slopes and negative slopes are not the same. So the slopes from the left and the slopes from the right are not the same, and we know that a limit doesn't exist when the limit from the left and the limit from the right are not the same as x approaches a. That's basically what we have going on here. So what we do, well, this is actually called a corner. Okay. And corners can occur on graphs if we've got the absolute value. Okay. So in general, a corner is going to occur for any x which produces 0 inside the absolute value. Okay, absolute value. So what we know here is that we have x minus 1 inside the absolute value. What value of x will cause there to be 0 inside this spot only? 1. So therefore we have a corner at x equals 1. And the function has a derivative which does not exist. Okay. And again, the idea is that the limit of the slopes from the left are not the same as the limit of the slopes from the right. So there's case number one where the derivative does not exist at a corner.